Hi, just wait one more minute and we start because still we I guess we should start. Just a gentle reminder that tomorrow we deadline for your second homework, and then the homework 3 will be uploaded. Just another reminder about is the peer review. So you can check, you can grade your peers, and if you figure out that your work is missing from the file, let me know. I mean, I'll put that back because I guess there's some problems when I download the data. If you submit your files in different batches, so let me know if your file went missing. Then I will just put that back to check that again because a little bit difficult when you submit file in different batches. So any question before we start? One tentative thing that you know is the probably I put that on the announcement will be the test. The single test of this class will be on the November 26th. Will be at night, 7:30 to 9:30. Will be online. So we figure out the details as I put that on the and the presentation will be at the last week. So I figure out how to handle it because it's online. So I would guess the logistic would be the same. I will put the Google Sheet that you can sign up for the group, and then the group will declare your topics. I make sure that no topic will be collided, and then you will work on a real-world problem. So the idea is probably like what you're doing in like your first assignment in some sense, but you're not going to do summary statistic, but you are going to do some analysis based on those. It's more or less like what you learn from this class, right? You will do some hypo testing, you will do some ANOVA or regression. So that will along that line. So I think you are not that ready to do the project because after I finish this week or next week or so, then probably you will be ready, but it will be more like an extended assignment. Peer review. I guess I give you 1 or 2 weeks, or maybe I give you 1 week or so. I put a deadline over there. I guess I give you maybe 2 weeks is fine. Doesn't really matter, I guess. Okay, I give 2 weeks from now, same as the assignment 3. Well, peer review, you just go online and then do with the Google Sheet. You can just grade them. Well, so if you grade, then I mean, grade them is part of the assessment, right? So if you don't want to grade it, then part of your, I mean, it's part of the assessment. So I'm not sure. I mean, you just watch, you just read the PDF and decide which one you think is above average, which one's average, which one below average, and that's it. So it's a 1-page PDF, right? So I guess it doesn't take more than a long time to do it. It's okay. I guess it's not something terribly difficult. It just at the first outlook you think it's good or bad, then you can judge, right? So then spend a lot of time on that. I guess you would consider, yeah. I think because of time, I guess my thinking is like because of we may have one assignment less, so probably I would just anyway. Any more question? I guess that would be. I don't want to elaborate on this part. I guess this a little bit technical. Yeah, that's all we need to just evaluate. Yes, the poster. Okay. If there's no more question, I suppose we should start because we don't have a lot of free time. So that's pretty much. So let's get started. So let's basically we try to finish the one sample and then start with two sample. Okay, so that is the goal of today. So just review. Can you see my slides? So I guess this this is part of the question, which says when you're one sample, if you know this sigma, then we have a z-test. If you don't know the t-test, right? I think we know there are three different types of z-tests. It's a depend on the null hypothesis, how you specify the alternate hypothesis. In particular, if you specify the alternative is the right-hand side, right tail test, right? Then you reject on the right. If you have the left-hand side, rejected the left-hand side. If you have not equal, then you both sides. Okay, so that's what we learned last time. And if instead we don't know the t-test, right? If you don't know the sigma, but instead of you use the s, which is usually the case, then we will be doing the same, right? Instead of using the z, then we use the t. Okay, so that's the only thing we have. So it's just basically just let us review this case and you will see the similarity. Okay, so we are now in slide 26. So consider the case where t test of left tail. So the now is mu equal to a, right? The alternative is mu less than a, right? And according to central limit theorem, and again using the t-distribution idea, right? So we would expect this, right? This is have center mu a, right? And we don't know sigmas. I don't know, that doesn't really matter. We can use s square, but when you s square, then this is no longer a normal, right? Then you will be this x bar minus mu over s root n will be a t n minus 1. Okay. So again, the same concept 0 here. You would be saying if the sample data you get is so much less than a, then you would question about the validity of the null hypothesis, right? So it's just like it's so far away. It's like here is so far away, right? And how you define so far away is by the probability, right? So it's so far away down there. And if this is less than alpha, is the threshold where we would say it's so far away, right? So in that case, it's somewhat like this here, right? This is this is alpha, and this is the critical value, which is given by Tn minus 1 alpha, right? Because one-sided, you put all the alpha here, right? Because the reason is the confidence is 1 minus alpha, okay? So that would be the non-rejection region is the probability that it is true you don't reject, right? So minus alpha, and this the significance level will be the complement of that. Okay, so let's see the example, and then you have a better idea on how things being done. Okay, and we're going to repeat that because the same idea to do the p-value. So let's see this example. Okay. Your random sample size N16, sample mean is 3, sample center is 2. Okay. This is what we said. Rejection on the left. Okay. Okay. So there will be 4 here. And what I expect is if far left from the left, okay, it's far below 4, then you reject. And then what's criteria reject is this area is equal to alpha, right? It's usually it's 5%. Okay. And what is this, the distribution of this looks like, right? You would convert it to T, right? How do you convert to T, right? You just minus the mean, the sample mean, right? So sample mean minus your mean is supposed to be 4, if this is true, right? The mean is 4, and S over root N. Okay. Because why this is the case? Because that is proven this is going to be a T distribution, N-1, right? Because we said that in the sampling distribution, right? This is we have proven, and this is 0, right? And the data tell us, okay, turn out that this is negative, turn out that this is 3, okay? And what is this correspond to here, right? -2, right? Because 3 minus 4, right? Over 2 divided by root N, okay? Is -2. And we want to know this area, okay? You can do this by p-value method, right? You can calculate this area, right? By just using this idea, and this is just T inward -2. Sorry, you have to put degree of freedom, right? 15. Okay. So this is what you do Excel, and turn out that this is the case. Okay. So maybe you can do Excel after we show how to do the rest. Okay. So this is how you get it, and this turned out to be less than 0.05. So it's actually it's not here, it's way inside, or we can just change this 5% to here. Okay. It's much less than 5%. Okay. So that is why you will reject the case, the null at 5% significance level. You would say we would be in favor of this one. And alternatively, you can calculate this value, right? How do you get that? You just look at this. 5% is how much this value. Turn out to be this is -1.753. Why is the case? Because how do you find this? Sorry, my bad. This should be this, because the distribution function. So this is, we have to T inward 0.05 and 15 will give you 1.753. Okay, and this number, as I said, is the 2 is less than that, so it's way extreme than this number, so we reject. Is that okay? So many of you ask again why we use 5%. This is usually if nothing is there, then we use 5%, unless the question stated otherwise. So 5% is a norm, unless you have some reason, and there's no particular reason why 5%, because historically people use 5%, and 5% is a appropriate thing we use. You can use 1%. So the standard thing is like the alpha is either 0.01, 0.05, sorry, it's point, and also 0.1. So it's correspond to 1 minus alpha correspond to 0.99, 0.95, and 0.9. And You may ask why. This is the standard way we use. You have to come up with some number, right? This is alpha is remember is the size of type 1 error. And usually we said 5% is a good one. So, and there's no particular reason why, but this is a convenient one. There's no rule why this is the case. But turn out to be this is the convenient one. Okay, any further question? Let us show you why these two are right. I mean, I will just quickly show you this case, right? T inward and T this, right? Let us check this out in the Excel. I check this out Excel. Let me share the Excel spreadsheet to show you this is the case. So I have to open Excel. I don't have Excel with me now. So let's wait. So let me share the Excel. Okay. So what I want to show is the two things here. I want to show T degree of freedom 15 0.005 is indeed equal to 1.753. Okay, and also the second thing is the probability that T15 is T15 is less than -2 is equal to 0.03197. Okay, so there's a two thing I want to show, and the first one the second one first involve the T distribution, right? So basically, it's T distribution, and then it's -2. Degree of freedom is 15, and always cumulative for our purpose. So that is, we prove this one. Second one, how do we prove it? Maybe I put the formula here. Okay, so this is the formula. And how do you get this one? It's T inverse, okay? It's 0.005, and you put 15. My keyboard has the 5, the 1 is a little bit problematic. But this is how you get this number, okay? Of course, I put 05 in the depends on how we define. So I just put this one, same thing. Okay. Is that okay? Any question? How we arrived at in the slide? Is there any question? If okay, then type okay, because that would be, we are not going to repeat that for the everything, every time we do the T, that would be if okay, then we are not going back to Excel for the moment, at least. Okay. Where are we? Go back to the slide. Where's the slide? Yes. So we're done with this. So we are going to two-tailed test. The same idea, just repeat again. Left-hand side, right-hand side, you reject on both sides. Okay? On both sides. Then you put alpha of T on both sides because T will be symmetric. Okay? So the same thing, I'm not going to go to the detail how to do it, but I will just go to the example directly. Okay? You can see my slide slightly different from yours because I combined this first bullet point, the second bullet point, because this is a method 1, right? Probably if you method 2, and then you can do either the method, right? You don't have to do one. You can just choose one of them, okay? Either you do the p-value method or you do the critical value method, okay? what is here is, let's do it again, this, okay? The null hypothesis said, according to the null, okay, this is 4 here, okay? And sample size is 16, and this is 3, and this is s is equal to, right? And we know we convert it to the t-space, right? Just again, there will be x bar minus 4 over 2 over 16, okay? And the alternative is not equal to, so it will be, you will reject if this is 2 away from 4, so there will be, you reject on both sides, right? And the alpha we set, right? So the standard thing is we set 1 minus alpha, usually we set 95%, okay? That means this is alpha over 2, it will be equal to 2.5%, okay? Same here will be the alpha 0.025, okay? There's no reason why we said alpha is 5%, but this is a convention, okay? There's nothing but convention here. And now the data we have is set is 3, okay? Okay. The question is it 3 inside this blue region or outside this blue region, right? So how do we go about that? Is right, convert it, right? As we said, convert t, this is 0. And the same logic will give you -2 because always the 3 minus 4 over the s over root n is -2, okay? So we want to calculate the 2 step, okay? We can use the step 2 or method 1, okay? And maybe we use the method 1 first, it will be. So this is the result, okay? The critical value is this one, right? Just to remind you what's critical value, how to find this is t inward, and it will be 0.025, you input 15. Okay, so this should give you this answer. And so that means the critical value, right? Because on the left-hand side, so it will be somewhat here. Okay, so this is the 0.025, negative 2.13145, and this will be positive 2.13145. Maybe I use the blue color to signify this is the same, to signify that the same thing as like this one. Okay, so this is alpha 2 here, alpha 2 here. Then it's not here, so we fail to reject. Okay, so in that case, we're not rejecting at the 5%. So there's no evidence to reject this is equal to 4. Okay, so you can see when you see one side or two-sided, the result can be different, right? If this is two-sided, then it's not reject. It's one-sided, you reject, right? You compare this case to before. So whether it's one-sided, two-sided is crucial, and you should make an educated idea why you have this, right? Remember why you have this is because violation of both sides will be a problematic thing, right? And how to do the p-value method, right? P-value will be saying that you're looking at the more extreme value, okay? So it will be this t more than bigger than this t, okay? This value. So absolute value is t here is 2, okay? So basically just calculate the more extreme tail area. If this side, you calculate this side, other side, calculate other side, right? And you multiply by 2, okay? Here the 2 is important because you compare this with alpha over 2, so that's why you multiply by 2, okay? And you calculate this, it's bigger than 5%, so you do not reject. So the key here, remember, is 2 here, so that would be a tricky part, If you forget it, then you will make a wrong decision. But is that okay? Any further questions? If you're okay, can type okay, because we will almost immediately finish this part quickly. Is that okay? Can I have your confirmation that you're fine with that? If you're okay, can you type okay? Yes. Great. Very happy that we don't have any problem on this. So here, the next, good. So the next part is somewhat, well, but simple, just mention about how to do proportion. And I think we just talk about the two-sided one because the proportion you can do both sides, two-side, one-sided, we're saying, okay? We are not going to argue, we're not going to give you every detail, but because it's a simple z-test, because remember the proportion, sample proportion P, right, will be a normal distribution, right? If the population was pi 1 minus pi over n. If you still recall from in the chapter of sample proportion, okay, this is something we have said. Hopefully you still remember this, okay? So, so that means if you follow this, right, the sample proportion P, okay, just remember this is called the sample proportion, okay? The pi is the population one, okay? So this will have this mean of pi, right? And a normal distribution, right? So that means I can go back to the z, right? And this is same 0, right? And I can check whether both sides, right? This is equal to A, right? I check whether both sides, right? Maybe other color. I check both sides, right? If this is alpha over 2, okay? I just do two-sided one. If one side you put alpha on, depend on your alternative hypothesis, okay? So you try to check if this is z alpha over 2, right? This is z alpha over 2, and then you can just try to tell you when to reject, right? Either use p-value method or use the critical value method, okay? So let's go over the example, okay? So this is the sample size n equal to 50. Sample proportion P is 0.05, okay? So we have 0.4 here, okay? So basically is the sample proportion, okay? Which is 0.4 here, okay? And this is the mean we suggest. And the data we have is something here, 0.5, okay? And then the main question is it far away from 4 on both sides, right? So the question is asking if you use the 1 minus alpha is 0.95, right? So basically asking the both sides some equal distance, right? And 0.025, okay? 0.025. Is this 0.5 within this purple region or not purple region, right? If purple region is far away from 0.4, if within, there's not, right? So it's whether it's that case. And so what you're going to do, right? Just the formula, remember, right? To convert this to the normal z space, right? This will become 0 here, okay? And you convert this. How do you convert this, right? Because this p minus pi over would pi 1 pi over n, right? So here's how we see 0.5 minus 0.4, 0.6 over 50 is 1.44, okay? So that means here is equal to 1.44, okay? And we use the usual method and see this, how this, right, 0.025, right? And using the Z table is 1.96, okay? How do we get this again? Just to remind you again, is norm S inward point 0.975, okay, because the left hand side is 0.975, okay, and same as here is negative 1.96, okay. So this blue region is outside, is within this non-rejection region, right? So that's why we fail to reject, okay. Or this is method one. The method two is calculate this area, right? It's calculate this area. Okay? It's probability times 2. Okay. So basically the p-value is taking the absolute value, right? You just z bigger than absolute value of that guy. Okay. The method is. And how do you do that? Right? This one will be the 1 minus the norm S this, okay, 1.44, of course, the true here, right? And then you 2 times this, sorry, 2 times this, okay? And this will be the answer. Okay, so you fail to reject. Is that okay? Now, so it will be good. Let's do it exercise before we go to break. So I think there's a 5 minute. I think it's a good question. Okay. Now, let's do the following. Okay. So let us do this alternative exercise. Maybe I just put it on the. Maybe I put it on here. Okay, maybe I do this question before the break. So let's have the following question, same as what we have seen, right? So the question is n equal to 50, right? Sample proportion is 0.5, right? So h now is pi is 0.4, okay? So now h1 is, this is the original question you can find there, okay? So this is the question we want to check, right? But now let's do the other question as exercise. So we say n now is 100, okay? P is 0.5, x0, pi 1 is 0.4, h1 pi 1 is bigger than 0.4. So let's do this together. I give you 5 minutes to do it, and then we'll figure it out. Okay, so let's do it, and then we'll break. So please try to do it if you have Excel in your hand. If not, then you can use your calculator, can also do. just wait a little bit. We will discuss this soon. Yeah. So 2 more minutes, then we will discuss. So if you are done, then you can tell me the result as Chakwa has said, whether you tell me whether you reject or you accept at 5% significance level. You can type the chart, then I know whether you're done or not. Or you can type me the p-value. If you're done, let me know you're done because I want to discuss when you're done. Is it okay? Yes. Can we have more reply if you're done? Yes. Good. So let me show you the steps because you expect to demonstrate your step when you do the exam, right? So you have to calculate the z test statistic, right? Which is z is equal to 0.5 minus 0.4 over root of 0.4, 0.9, 0.6 over 100, okay? And this is 0.1 over 0.04889. This gives you 2.041412. Okay, so this is the answer. I showed the Excel how we get it, but I think this is calculator, you know how to do it. And method one involve finding critical value, right? The critical value, C 0.025, right? It's 1.95, right? Since this Z, right, is bigger than the Z 0.025, so you reject external at 5%, okay? The second method, we're getting the p-value, right? The p-value is equal to, this is positive, right? Or whatever is this is probability that we define alpha as the right tail. So that's why, depend on how you define this, because I think in the book we define this. Let me write down here. So in the book, in the problem, we define z bigger than z alpha is alpha, so it's the right tail. So that's why. Is that okay, Peter? Yeah, it's a right tail. I mean, this is how we define. Of course, you look at some book might have defined this way, right? So then you would negative out. I mean, you would do the other way around, but we define this way. So the right tail thing, and the p-value will be whether this value z, right, is bigger than z, right? So it's 2 times the f, right? Actually give you, I don't want to elaborate, it will be 0.041127 because I will show you how to do Excel. Okay, so this is the answer. And let me show you how we do the Excel. Right. Can you see the Excel spreadsheet here? Can you see Excel spreadsheet? So it will be n equal to 100 and pi is 0.4, p is 0.5. So the standard error, which is square root of 0.4, 0.6 over 100, right? And z will be this, the p minus pi over the se, right? And the critical value will be look at 0.75, right? So it's 1.945, right? And the critical value will be 2 times of 1 minus the distribution, right? They give you 0.4, so it's because it's two-sided. So someone asked me why alpha is 0.025 is two-sided. The question is, do I use the other one? Oh yeah, sorry. I should, yeah, very good question. I should use 0.5. Yes, I guess because I use two-sided, so I should use 0.5, 0.05. 0.05, then it should be 1.64. So it should be 1.64. Yeah, thanks for pointing this out. So it should be this, and then I should change my Excel. Should be 95. Yeah, thanks for pointing this out. And the p-value is I don't need the it's not two-sided now, right? So it should be one-sided. I don't do multiply by 1. So because this is a one-sided one. Sorry. Just a notice. So it's half of that. So the answer should be 0.02, so 6, right? So anyway, you also reject at 5% significance level. Okay, thanks for reminding me because I forgot I changed the sign. Okay, any further question? If no, then we will break of 15 minutes and we'll come back to sample. Although we finish one topic, I think it will be more beneficial to have the quiz only if we finish the whole set of slides because it's so similar. I guess there's no point of having too frequent quiz. So we combine the 6 and 7 quiz together. So there will be no quiz. Although we finish one topic, then I guess it might still be better to wait until we finish the whole hyperpass testing. Okay, so let's have a break of 15 minutes. So we come back at 1:35. So I guess we should resume. But before we resume, any question about the one sample test? One sample test. If no, then we go to the slides again. So let us very briefly to talk about the two sample. Okay, so it would be very similar to one sample. Okay, two samples means that you have doesn't mean you collect two samples. You can imagine that you have one sample, but there's a categorical variable binary data to divide the data into two parts, right? Say suppose you collect data like the GPA, right? And you also collect data of the gender, right? Then you can compare the gender, right? Whether say boys are better than girls or better than boys, and so on and so forth. Or you collect their faculty, whether they belong to B school or not B school, then it's two set of data, right? The two sample doesn't mean you actually collect two sample, but the data can be collected in two parts. Okay. So here we what we are doing is comparing the mean, whether the data have different mean, and you can see here we only compare two different case. Either you are belong to one group or not, right? Or even there are two group. Okay, and after this topic, we talk about ANOVA. That will compare mean of more than one group. Okay, so ANOVA will be an extended case of we cover now. Okay, so when you have two groups, there are two types of two samples, right? So let me give you the idea here, right? We mentioned about data, right? The data, okay, can be naturally divided in two groups, right? Maybe this is male and female, right? There's a standard two group, okay? And there's several assumptions you can make on this two group, right? Might be they have the same variance, okay? And this is the first case we have is the two group with equal variance, okay? And they may not have equal variance, two group, without equal variance or different variance, okay? And the third case is these two groups may be related, okay? In the following sense, maybe you're thinking about the data is there some patient, right? And the observation will be you give the patient some medicine, right? And this is before, this after, okay? And you have for each data point before, you have other data point after, right? So this is before, this after, right? And you basically how you get here, you get some drug, right? Or some treatment. And what you want to see here is you want to care about whether the drug is useful, right? So you would care about the difference. Okay, the difference. Okay, and each observation has link, natural link between two groups. So this is called the paired data. Okay, so there will be three things we consider, three cases. One is compare the mean, you have compared two groups. Okay, either they have same variance and the different variance, and or they're paired. Okay, that's the three cases we consider for comparing the mean, and then at the very last we also compare the variance. But that would be the four tests. Okay, this is compare mean. okay? And also we compare variance of two groups, compare variance, but that would be asking whether, say, M and F, all right, whether the sigma M is equal to sigma F or not. Okay, so this is you have two groups of data. You want to see whether different group have different variance. Okay, do note that for this, the third case, right, is pair. So we require the sample size NB is equal to sample size NA. Okay, and for other cases, you don't have this restriction. Okay, it can be different size, it can be same size. Okay, but before we start, any question? So this is the outline that we're going to cover for different tests. Okay, we want to see the two group of data. If the same equal variance, what is whether the mean are different? Okay, it's very natural to ask this question, right? Because we want to know, oh, this is it product going to be useful, or you look at the consumer survey, look at the male and the female, is it going to be give the same mean, right? And also in audit cases, right, you would expect different company maybe have different warehouse, right? And two warehouse will not have too much different outcome, right? Then you should just pick up here and put up there. Look at this warehouse, how many cases here, and those other another warehouse. Look at the mean, and you compare the mean, right? Then you can check whether that's the case, right? And finance also the same, right? You want to see whether the two different strategy give you two different return, right? And then you want to see whether two different strategy actually the same or not, right? And depends on whether you make the assumption whether they have the same variance or different variance, equal or different, right? And how you get these two usually come from other tests, right? Tell you whether it's true or not, or you have some prior knowledge about whether they're equal or not, right? And also the pair is also very useful, right? So there's a very useful technique, okay? Then you expect to, you encourage to think about this, and because that might be something you want to do in your project, right? Compare the mean and go, right? Because that would be, I guess that would be from two sample size, two sample t-tests, also the f-test, and also the ANOVA or regression are the things that you want to work on your projects, okay? Because this is something that is more substantial, it's more fun. Besides what you want to do interval estimate, okay, or those kind of things. But these are more interesting questions you can ask in your projects. But any question before we start? To make sure you are here, maybe you can type okay, you okay? Okay, that's good. At least 3 or 4 people are around. So let us go to the question, okay? So the null is going to say whether they have the same variance or they have different variance. Okay, so that is so it's same mean or different mean. Okay, so the first thing we start with equal variance. Okay, they're the same variance. We don't know what it is. Okay, that only we just said that they're the same. Okay, and why you think they're same? Maybe you just collect over time. You don't think the variance changes, right? Maybe you observe the data this week and last week, then you, for the same set of customer, right, you randomly drawn from there, then probably it's okay. You want to see whether they've changed the idea. Okay. So the turn out that this, right, if this is true, okay. So what it's saying here is you have collect data x bar 1 and x bar 2, okay? So this sample 1, there's sample 1 and sample 2, okay? And from sample 1, you draw x bar 1. From sample 2, you draw x bar 2, okay? And also you can do S1 square and S2 square, right? They're the sample variance, okay? And if you said they're the same mean, okay? And do note that this is, okay? Do note that x bar 1 minus x bar 2, right? We have the mean mu1 minus mu2. To be exact, what I said is this way, right? The mean will be equal to this, right? And turn out that, right, which I think we will prove, or we don't prove. Now we will have a proof. Proof this is normal with mu1 minus mu2, and the variance is the denominator, okay? So basically, we will explain why this is true, but this will be the difference of the sample mean will follow this normal distribution with this guy, okay? And what is SP here would be a somewhat complicated object, okay? So let's see. This SP is a kind of looks weird looking object, right? We call the pooled variance. This S1 and S2 kind of where weird is N1 minus 1, N2 minus 1 is a weighted, it's a fraction, right? It's a fraction. And this under fraction, right? This you can see this plus this equal to 1. Okay, we explain why this formula is like this, why we have such a formula, but this is the, but that would be the key here, and the test two-tailed, if you do two-tail, right, that would be this value, okay? Of course, if you do one tail, then will be N1 plus N2 minus 2 alpha plus minus. It depends on what side you're using, okay? And is that okay? We give example, of course. And you should not be surprised the interval estimator, okay? If you try to predict the difference in mean, we'll use the point estimate, right? And this will be the interval, right? Will be T, and this is the standard error, okay? So this will be the somewhat standard way to do it, okay? Maybe we'll give you an example and then you will see how this can be done. I guess that would be more fruitful to look at the example because this is nothing but just we change from one sample to two sample and then with new formula, okay? So, so we have two population have the same population variance, okay? So that's why this formula applies. And we have sample size, 1 is 50, so N1 is 50, okay? And X1 is 40 and S1 is 4. And the other one, we have N2 is 40, so this N2 is 40. X2 is 42, S is 3, okay? So what we are saying is we trying to see whether they are the same mean or different mean, okay? And by appearance, they seem different, right? The difference 2, right? If they're same, you should expect this x1 minus x2 should be somewhat like mean 0, right? Okay. And now what actually found is 2, okay? Again, because this minus this is 2, right? So what you've tried to see, because you have two-sided test, we try to see this area and this area, right, of alpha over 2, alpha over 2. we want to see this Q is within this blue region or not. Is that clear what we're trying to do? Is that okay? Okay. So the first thing to do for this question, what we need is to estimate, because the same variance, okay, which the formula we call pool the variance, right, will be somewhat a funny expression, which is very funny. We just n1 minus 1, n1 minus 1 plus n2 minus 1 times s1 squared, n2 minus 1, n1 minus 1 plus n2 minus 1, s2 squared, okay? So that's why you have 4 here, n1 is 50, n2 is 40, and s2 is 3. So give you the pooled variance is 12. Is that okay for this one? Okay, so in some sense, this the sample variance for S2 square, right, is 9, and this S1 square is 16, right? So actually this one should be in between the two, right? Because this is a weighted average, right? It's like it should be between these two numbers, right? Because this is, you can imagine this is alpha, is 1 minus alpha, right? Not alpha, maybe not use alpha, maybe you're confused, but you can imagine this is a proportion Q, this 1 minus Q, right? So they are summing to 1. So now with the SP, then we can basically do all the calculations. So we do the T statistics, okay? We will do the T stat, okay? So the formula again will be x1 minus x2 bar over the SP square, 1 over n1 and 1 over n2, okay? And n1 is 50, n2 is 40, and SP we have found is 12 from something, okay? Turn out to be negative 2.625, okay? So just to remind you what we are doing here, okay? This is 0, right? Actually, that's not different from here. It's also 0, okay? The difference is 0, right? But the only difference is the variance, right? And this difference is 0. And what we have is negative 2 here, because I think x1 minus x2, right? Negative 2. So we want to see whether the both side, right? Alpha over 2, okay? Whether this negative 2 is within this alpha over 2 area, right? And if you use 2 and you convert it to this T space, okay, it's negative 2.625. How you convert this from here, right, is x bar minus x1 bar minus x2 bar over square root of SP square 1 over n1 plus 1 over n2. Okay, so this is the formula we have, how to convert this here. And now we have to look at this. Remember, T has a little bit, you have to check, right? With 88 because it's 40 plus 50 minus 2, okay? And you see it's minus 2, it's not minus 1. Later you see why, but because we will have 2 samples minus 2, 1 sample minus 1, okay? It's one way to remember. We'll prove y minus 2 soon, but this is 88, okay? So you look at this, what's critical value here? Okay, just to remind you how you found this is T inward, okay, is 97588, okay, and it's 1.978, okay. So which means that if you use the purple color again, okay, it's actually here, negative 1.987. Here is also the same. Give you 1.897. This area give you the, some of them is give you the 5% area. And since the red is less than the purple one, right? So you reject at 5% significance level, okay? And you can do the same for the p-value, okay? And you would do the same, look at the absolute value, look at how this value bigger than this times 2, right? This is how you do the p-value, right? One-sided, you just do one, you forget about the two-sided is 2 times what's one-sided value, right? So that would be this, how you figure this out, right? This is just 1 minus T inverse T dot this, okay, 2.625, of course true, okay. So that's how you get this number and multiply by 2, so just to be, this is what we do Excel, right? So that one or face a typo here, it's less than, okay. So that would be, you would also reject. Is that okay? Any question? So it's rather mechanical, but no, this is standard way you want to see, okay? Since they are different, okay, so now it makes some sense to do this estimate, right? Because otherwise it doesn't really make too much sense. So why P is 0.05? Just standard alpha. Is that okay? Check what? Are you asking why this is true?喂，
如果我最尾計到個 p-value， 即係而家係0.0102啊嘛，即係如果我最尾計到係0.05，即係啱啱好等於嘅時候，我哋係accept 佢啊 reject 佢啊。
Okay, so the exact question is what happens if you exactly this one? Usually you will not have this case, but usually doesn't really matter. Depends on whether you use the exact one. So I'm not sure. Let me check the textbook. What happened if you exactly? Let's follow the textbook. I guess it doesn't really that matter, but I don't know what the textbook said. Let's see. The textbook was said when it's equal, I think you reject. Yes. According to textbook, when equal, you also reject. Reject if you more than. Otherwise, you do not reject. So textbooks, that means P is equal and you do not reject. Okay. The textbook would say if equal, you do not reject. But I guess it's exactly equal, then I guess it shouldn't be that matter. Usually you don't have this exact one, but the textbook would say you do not reject, because they said the reject if less than, so when it's equal to, you do not reject. So that is so that's how it is, and how I write in my slide reject. Okay, in the slide I do different thing. I said not less than or equal to. So I guess doesn't really matter. When it's exactly equal to, then you can just reject or not is fine. I don't see, because this is probability is like very unlikely, but the rule doesn't really matter anyway. So if you do not reject, right? So which means that the sample, they have different mean, right? Then it makes sense to continue to do this confidence interval estimate, right? So estimate what's the difference, okay? Then how you do it is, as we said, right? X1 bar minus X2 bar, and this is the T put in here, right? And this denominator over there, right? Then this will give you the interval. Okay, so that would be you are predicting. Okay, is that okay for this one? If there's no problem, then I will just continue to show the proof. Y with n minus 2 here. There's some short proof. Okay, shouldn't be a big deal. Okay, what we want to show, okay, because we're using a T distribution, right? So what we need is to show this is the case. This is normal, and the denominator is chi-square, and the ratio of this gives you the T. Okay, so that would be the T n minus 1 plus n minus 2 minus 2. Okay, so let's get started. Okay, the first one is variance of the difference of the mean, right? And here we have independent sample. Okay, so that's why the variance of the two will be the sum of them. Okay, and they have the same variance, sigma, so it's sigma over n1 plus sigma over n2, right? Because variance of x bar will be 1 over n sigma squared. This is we show it in the topic 6. Okay, so x1 will be n1, x2 will be n2, so it's sum of that. Okay, so that justifies why we have this, right? Because this is the mean is assumed to be 0, right? So minus the mean over the variance, because they're normal, so this will be the standard normal. Okay, so we prove the first part. Is that okay? Now we prove the second part. How do you prove the second part? It's not that difficult, also rather simple. Okay, it's just utilizing what we have said in the sampling distribution, right? This summation different from the mean over sigma, right, is equal to n minus 1 times this S1, right? I think we just remember what we have said in this. Sorry, I think this is also the same thing we have said in the last class, not last class, but I think a few classes before. Okay, and we already said this one is chi-square n minus 1. This is coming from the chi-square. Okay, this is we proven that. What should we input for the degree of freedom? Oh, sorry, just go back to this. This 88. N1 plus N2 minus 2. So how do you figure this out? This is just T inward, right? 0.975 88. Is that okay? Tan N? So go back to the proof. So this is actually coming from what we learned last time, right? This is, they are independent, right? And this is chi-square N1 minus 1. And the same logic goes, this is N2 minus 2. And the sum of them, right, will be chi-square N1 plus N2 minus 2 because they're independent, okay? Sum of the chi-square is just chi-square, right? With adding degree of freedom. That's why N minus 2 here. And because as we said, they're all independent, right? They are all independent, so this independent thing, okay? So the numerator, the first bullet point, and the second point bullet point, okay? This will be Z over the chi-square, okay? And do remember this guy, right? This is SP, okay? So that's how SP comes from. Okay, so that's how you get what we get. Is that okay? So that's how you get T distribution. Any question? No? Okay. So now we quickly go into the next one. That would be also little bit simple. Okay. We have unequal variance. Okay. Also independent. Okay. So with two population, X1 and X2. Okay. The population. And we draw some sample out of it, right? And we're saying that they have the same mean or different mean, okay? And turn out that the test statistics, okay, will be this minus and it is 0, right? And the standard error will be somewhat easier, okay? Will be just S1 over N1 plus S2 over N2, okay? And here this complicated thing we have degree of freedom is V, okay? So that's a little bit tricky, okay? The formula seems simple, but how you get this V is rather clumsy, and we don't prove it because this is something beyond our class, and you never found them in the basic statistics class, okay? So where the V is, this critical value, V will be equal to this funny formula, okay? This degree of freedom is somewhat beyond our understanding. There will be something with this. There's some proof. We don't go over that. Is way beyond what we covering. And you calculate this number, and this is called the integer function. So basically, this is called round up. Okay. So if turn out to be 9.8, you give 10. If you get 9.1, also you get 10. Okay. 10.1, you get 11. Okay. So it's a round up. Okay. Round up or round down? Sorry. Sorry, it's a floor function. Sorry, it's not round up. So if 10.1 you get 10, 9.8 you get 9, 9.1 you get 9. If 10.2, you also get 10, If 100.1, you get 100. If 99.9999, you also get 99. Okay, this is the round, not one down, sorry. It's a floor, this is a floor function. Okay, always one down. Okay. And so the interval estimator is T, right? This is SE. Okay, this is SE here. Standard error. Okay, so this is much easier, except this V is a little bit different. Okay, so then let's go to the example and show you. Okay, so it's rather mechanical. So we have samples. First sample N1 is 50, sample mean is 40, and the sample one is 4. The other one, N2, is 40. N2 is X2 bar is 42. S2 is 3. And do not have the same population variance. Okay. Okay. And that means that we will have to use the function we have just known. Okay. So the T is rather simple, much easier to calculate, right? Just like x1 bar minus x2 bar and s1 square over n1 and s2 square over n2. Okay. This is much way simpler. Okay. So you plug the number in, right? We give you this number. Okay. And then you need to check the critical value, right? Again, the same idea. Let's repeat a little bit, right? You want to check this x bar, x1 bar, x2 bar, right? You want it to be 0, right? Then you try to check, right? You figure out this is actually -2 here, right? And then you convert it to the t space, right? And turn out to be -2.709. Okay. You want to see whether this is this alpha over 2, right? Is it the case, or it is other way around, right? Whether this red area include -2 or not, right? So you need to check the t value, right? T, V, alpha over 2. Okay. And what is the V here? This is the most complicated thing to calculate. So let's see. Okay. So there is something beyond our understanding, but it is a complicated formula. Just to recall, S1 square over N1 square. Luckily, your exam is not, you don't need to remember this, right? But just some formula, right? 1 over N, 1 minus 1, S1 square over N1 square. And see, I can't recall. I just, so rather crazy thing, right? And this crazy expression gives you 87 point something. So you run down, give you 87. Okay. And because this two-tailed test use alpha over 2. Okay. Alpha is 5%. Okay. It's because of it's two-tail, right? Depends on whether you do one tail or two-tail, right? So here I use two-tail. Okay. So how you do this, right? It will be T, right? Inward 0.975. Degree of freedom is 87. Okay, 87 from here. Okay, and remember when we have the answer is the test is -2.709. right? So just go back to here, 0, right? This is t. This is negative 2.709, okay? And you figure out that the 2.5% are all here, okay? That means that you reject X now, okay? And the same idea, you want to do the p-value, right? You want to see this area and times 2, right? I'm not going to write down Excel formula. I hope you're able to see it, and then you reject, okay? And you apply the formula, right, to calculate the, right? This is the denominator, right, for the test statistics, okay? So that would be the case. So let me spend 1 more minute to explain why this formula works, just because we don't give the proof, just give idea. So we complicate a problem, turn out that someone have shown this guy, we don't prove it, will be a T with this degree of freedom, okay? And in actual practice, we don't know sigma, or then we replace the S by sigma. So that's how that formula comes about. And we run down to be rather run up because we want to be conservative. So that's how we actually do our calculation. And I guess that's the end of today. Just reminder that you will be submitting your homework tomorrow, and then homework 3 will be available. And I will put the announcement about the project and also the test in the black box. Okay, the text will be November 26th, as we have said in the syllabus. It'll be at night, so that to tackle the time zone problem. Okay, so that's the end. Have a nice weekend. I will see you next time. Bye-bye. The deadline that review, I will give you 2 weeks. Same as the deadline for next homework, 2 weeks from now. 2 weeks from tomorrow. Yeah. So I answer any question you might have. Thank you very much. Have a nice weekend. Enjoy the Halloween if you do. Don't eat too much candy, though. Let me know if you have any question. I'm happy to answer that. Any question? Please let me know.